This is the beginning of Unit 6, Week 1, Lecture 2. In this in this lecture, we're still working on the unit energy from electron transfer. And the question we're answering in this particular lecture is, what is a redox reaction? Now, you probably already know what a redox reaction is if you completed the POGL oxidation reduction activity as I requested. One thing I need to tell you guys is that sometimes in a redox reaction, or when people are talking about the process of oxidation or reduction, they use different language. Instead of sometimes saying, oh, that particular species undergoes oxidation, rather it's called the reducing agent, or oh, that species undergoes reduction is called the oxidizing agent. And so we have different terms depending on the context and whatnot. So I need to point out to you these terms. Oxidizing agent is the species that causes oxidation. Therefore, it's the species that undergoes reduction. And the reducing agent is the species that causes reduction. Therefore, if it's causing something else to be reduced, it must be providing the electrons, so it is the species that's undergoing oxidation. So I just want to go over this with you briefly. You should be able to identify the oxidizing and reducing agents in this particular example. So of course, the first thing you need to do is you need to identify, is it a redox reaction? And if it is a redox reaction, what is undergoing oxidation, what is undergoing reduction, and from there you can identify what is the oxidizing agent and what is the reducing agent. So here we go. First, you're just going to label all of the oxidation numbers across the reaction. Of course, hydrogen is always +1, so I can just go through and take care of that all the way across, +1. Oxygen is always -2, so I can go ahead and put that in -2. -2 for each oxygen atom in that compound. Now that just leaves me with the sulfur, apparently. And in this particular case, the hydrogen, there's 2 of them, so that's a +2, so the sulfur must have a -2 oxidation state. In this case, the oxygen is -2, there's 2 of them, so the sulfur must have a +4 oxidation state. In this case, it's just elemental sulfur, and so therefore it's just 0. And so what you see here is that the hydrogens and oxygens don't change. And on this side, we have a total of 3 sulfur. 2 of them have a -2 oxidation state, and 1 of them has a +4 oxidation state. And over here, we have 3 sulfurs. All 3 of them have a 0 oxidation state. So this sulfur is changing into 2 of those sulfurs, and this sulfur is changing into the other sulfur to make a total of 3. So the product is the same for both what we would call the oxidation and the reduction. They're both changing into elemental sulfur. So which is the oxidation, which is undergoing oxidation? Hydrogen sulfide or sulfur dioxide? And in this case, the sulfur is going from a -2 to a 0. That means it must be losing electrons. So if it loses electrons, then we know it's undergoing oxidation. And in this case, the sulfur is going from a +2 to a 0, because remember, we have a total of 3 sulfurs over here. Really, 3 sulfurs. And the 2 from here are undergoing oxidation, and then the 1 from here is gaining because it's going from a +4 down to a 0, so that's a gain of electrons, so that's undergoing reduction. Okay, and so then the question is, identify the oxidizing and reducing agents. So whatever's undergoing oxidation must be the reducing agent because it's allowing reduction to occur. Okay, it's the agent of change, so it's providing electrons such that reduction can occur, so it's the reducing agent. And then the sulfur dioxide must be the oxidizing agent because it is accepting electrons and allowing something else to undergo oxidation, so it's the oxidizing agent. All right, so that's just a little FYI. The terms, sometimes it depends on the context. Something will be said, it'll be said this hydrogen sulfide is undergoing oxidation, or sometimes it'll say hydrogen sulfide is acting as a reducing agent. Either one, and you need to be able to go back and forth between the 2 words. Okay.